Hi students, today we are solving some examples of rotational dynamics. So first example is somehow an ant is stuck to the rim of a bicycle field of diameter 1 meter. That means here diameter d is given, d is equal to 1 meter. So from the diameter we can calculate the radius, r is equal to 0.5 meter. Next, while the bicycle is on a central stand, the wheel is set into rotation and it attains the frequency of 2 revolutions per second. That means here frequency n is given, that is 2 revolutions per second in 10 seconds. That means t is equal to 10 second time is given here with uniform angular acceleration. Then calculate the number of revolutions. Suppose n is the number of revolutions completed by that ant in these 10 seconds. So this is the final frequency. So whatever the initial frequency, we can write that n0 is equal to 0 revolutions per second. So here also we can write what about the omega is equal to 2 pi n. This is the formula. Already we know the n is equal to n. Omega 0 is equal to 0. n0 is equal to 0 in that case, because omega is equal to 2 pi n. If n0 is equal to omega 0 is equal to 2 pi n0. So n0 is equal to 0. So omega 0 is equal to 0. And what about the omega? Omega is equal to 2 pi n. N is equal to 2 seconds. So 2 into 2 into pi, that means 4 pi radian per second. That is omega, and omega 0 is equal to 0. So we have to calculate number of revolutions completed by that ant, that is n is equal to question mark, and second in that 10 seconds, and second time taken by it to complete first revolution, that means t1 is equal to question mark, time taken by that ant to complete its first revolution, and the last complete revolutions means t10 minus t9. This is the time to complete the last revolution by that ant. t10 minus t9 is equal to question mark. So first formula to calculate the number of revolutions by that ant, that is n is equal to theta upon 2 pi. This is the formula to calculate the number of revolutions. We must know about the theta. Theta is not given here, so we use the formula for that. Theta is equal to omega 0t plus half alpha t square. This is the kinematical equation, and by that kinematical equation we can calculate the theta. So alpha also not given, alpha is not given here. So first we calculate the alpha. Alpha is equal to, so alpha is equal to omega minus omega 0 upon t. So omega is given here. Omega is equal to how many? Omega is equal to 4 pi minus omega 0 is equal to 0. So 4 pi minus 0 divided by time is given 10 seconds. Okay, so alpha is equal to what? Alpha is equal to 2 pi by 5. 2 pi by 5 rad per second. This is alpha, value of alpha. Now use in this equation, so we get that theta. So theta is equal to omega 0 is 0. 0 into 10 means 0 into t plus half. Alpha is equal to how many? 2 pi upon 5 into t square. That is t square means 10 square. This completely becomes 0. So theta is equal to, we get this 2 get cancel, 5 or this 10 square means 100 pi upon 5. That means we get the 20 pi. Theta is equal to 20 pi radian. In this way we calculate the value of theta. Theta is equal to what? 20 pi radian. So we are using that formula. N is equal to number of revolutions. N is equal to theta upon 2 pi. Already we calculate the theta. That is 20 pi upon 2 pi. That means pi get cancelled and we get the answer 10 revolutions. So first answer is correct here. answer is 10 revolutions. Okay, this answer 10 revolutions. So we calculate the first answer, n is equal to 10 revolutions. So we go for the t1, that is time taken by that ant to complete its first revolution. For the first revolution, we know theta is equal to 2 pi. First revolution, theta is equal to 2 pi. So we are using that similar kinematic equation. Theta is equal to omega 0 t plus half alpha t1 square. So we have to calculate this t1, that is time taken by the ant to complete its first revolution. So 2 pi is equal to what? 2 pi is equal to theta is equal to 2 pi. So we use 2 pi is equal to this 0 into t, means we can directly write here 0. Half alpha is equal to how many? 2 pi upon 5 into t1 square. Okay, now this 2 into 5 means 10 goes here, that is 20 pi upon 2 pi is equal to t1 square. So t1 square is equal to how many? Pi get cancelled, that means this 10. So t1 is equal to what? t1 is equal to under root 10 seconds, or when we can find the square root of this 10, that answer is square root of 10. In log tables, square roots of 10, 3.162, that is the square root for 10, 3.162 seconds. This is the second answer. That means this is the time taken by that ant to complete its first revolution. Here given t first or t1 is equal to under root 10 seconds. This answer is given here. Then go for the next one. So we have to find the time taken by that ant to complete its last revolution. So we must know about this last revolution. So for that, t10 minus t9 we have to calculate there, but we must know the value of that t9 by using the same formula, that is theta is equal to omega 0 t plus half alpha t square. Now for first revolution we take the theta is equal to 2 pi. For ninth revolution, what about the theta? That is 9 into 2 pi is equal to omega 0 is 0, 0 into 10 means 0 plus half alpha, here t9 we can write here, t9. Alpha means how many? Into alpha, value of alpha 2 pi upon 5 into t9 square. So 10 into 2, 2 into 5 means 10. 10 multiplied with this, that means this 90 into 2 pi divided by 2 pi. 10 into 2, 5 into 2 means 10. 10 into 9 means 19. 2 pi as it is. And this 2 pi divided by is equal to t9 square. 2 pi get cancelled. So t9 square is equal to 90, that means t9 is equal to under root 90 seconds. So we can calculate that t9 under root 90, value of that is equal to square roots under root of 90, 9.487 9.487 seconds. This is time for t9. So we have to calculate the time taken by that ant to complete its last revolution, that means t10 minus t9. Already we know that t10, that is time is given, so we can write there t10 minus t9 is equal to t10 given means that is 10 seconds already given, 10 seconds minus t9 now we calculate, that is 9.4887. So 10 minus this one we get that magnitude near about 0.513 seconds. This is the time taken by that ant to complete its last revolution. This type of question is asked for 3 marks. So we take the next question, 30 number, that is given in our book. this one. Yes, the coefficient of static friction between a coin and a gramophone disc is 0.5. That means force of coefficient of static friction is given. That means mu s is given. Mu s is equal to 0.5. Radius of that disc, radius is given, so we can write that radius r is equal to 8 centimeter. That means that it's converted into meter. 8 into 10 raised to minus 2 meter. Initially the center of the coil is 4 pi centimeter away from the center. That means that is the r. We can say initially the center of the coin is pi centimeter. So we can distance of a coin from the center of disc, so we can write that distance is r is equal to how many, that pi centimeter. That means pi into 10 raised to minus 2 meter. We are converting that centimeter into meter, away from the center of disc. At what minimum frequency, will it start sleeping from there? So first we have minimum frequency, that is we can write n1 is equal to question mark. By what factor will the answer change if the coin is almost at the rim? Use g is equal to pi square meter per second square. Okay, so we have to find by what factor. That means what about the second frequency? So n2 minus n1 by is equal to question mark. By what factor will the answer change if the coin is almost at the rim? So we have to calculate here. n1 is equal to question mark, and second one n2 minus n1 is equal to question mark. So in this problem we are using the two formulas. That is, first one is the Fs, force of static friction, is equal to mu s n, and second one is the centripetal force. Fs is equal to mr omega square. Okay, now by using that two equations we can write mu s n is equal to mr omega square. Okay, n means that is the mg, so we can write mu s mg is equal to mr omega square. This m get cancelled, so we get mu s z is equal to r. So frequency, so first n1 and n2 is considered there, so we can write here omega 1. So omega is equal to what? Omega is equal to pi n. So if we write here n1, so that means that is omega 1. So we can write omega 1 is equal to pi, here omega square, so we can write here 4 pi square n1 square. We have to find the magnitude of this n1. So n1 is equal to, make the formula for n1 square is equal to what? N1 square is equal to what? This mu s g upon 4 pi square r. That means n1 is equal to what? N1 is equal to under root mu s g upon 4 pi square into r. Put the magnitudes of that. Mu s is given 0.5 into g is equal to that also given, that is pi square divided by this 4 pi square into r is given there. R is equal to pi into 10 raised to minus 2, that also given. This square, okay, this square get cancelled, so n1 is equal to, we get that answer as this 5. So in this answer we get like 50 divided by 4 pi 10 raised to minus 2 here, that we get take that here, that is plus 2. Plus 2 means what? 0.5 plus 2 means we directly convert that into 50. So 50 divided by 4 pi or is equal to under root 25 upon 2 pi, or we can write 5 upon under root 2 into 3.14. If we calculate this all, then we get the first answer, that is n1 is equal to 2 revolutions per second. This is the initial frequency or first frequency, and second we have to calculate that at by what factor will the answer. So for that, n2 minus n1. So by using that same equations, we can write that equations as mu s n is equal to m r omega 1 square. For the, in this condition we consider that as that both in that both case FAC is the same. In that case we can write that equation first, mu s is equal to mr omega 1 square, equation 1, and second mu s n is equal to mr omega 2 square, equation number second. From that equation 1 and 2 we can directly write r omega 1 square is equal to r omega 2 square. Here get cancel. But we know that omega is equal to what? 2 pi n1, and omega 1 is equal to 2 pi n1, and omega 2 is equal to 2 pi n2. So we can write that as, now in this condition, second condition, so we can write that equation as omega 2. That means in this condition, this we have to consider that r radius is given that at the rim, okay, and this is the distance, first distance. So first is small r and here capital R, so we write here capital R. Okay, so r into omega 1 square 4 pi square n1 square is equal to r into 4 pi square n2 square. So we have to calculate here n2 square upon n1 square is equal to what? Then this 4 pi square get cancelled. That means what is remaining there? Small r upon capital R, only that is remaining. We have to calculate here n2 upon n1. Take the square roots of both sides, so we can write here small r upon capital R. Both values are given here, so small r is equal to what? That is pi into 10 raised to minus 2, that is given, and capital R also, that also given, that is 8 into 10 raised to minus 2. So that answer is equal to under root, this get cancelled, pi upon 8, that means under root 3.14 divided by 8. When we calculate this, we get the answer n2 upon n1 is equal to 0.63. So this is the second answer. Here answer that 0.63, that also given, n2 upon n1 is equal to 0.63, and n1 is equal to 2 revolutions per second. That is the second answer for that. Then this is the second problem. Then the next problem is this one. A part of a racing track is to be designed for a curvature of 72 meter. That means r, that is given 72 meter. Then we are not recommending the vehicle to drive faster than 216 kilometer per second. That means this is the phi max is equal to 216 kilometer per hour, that is given. With what angle should the road be tilted? So we have to calculate here theta. With what angle? Theta is equal to question mark. By what height will its outer edge be? That means here we have also calculate height. H is equal to question mark with respect to the inner edge if the track is 10 meter wide. 10 meter wide, that means L is given here. L is equal to 10 meter. Okay, so suppose this is track, this is height h, okay, this is equal to 10 meter, that is L is equal to 10 meter, that is given. Then this is B and this angle is theta. Okay, so we have to calculate that first theta. So tan theta is equal to, already we know that the formula, tan theta is equal to phi square upon rg. So first calculate tan theta, then we go for the theta. So tan theta is equal to phi is equal to 260 kilometer per hour. So we have to convert that kilometer per hour into meter per second. So how to convert that? That means phi max is equal to 216 into 5 divided by 18. So that is converted by multiplying by 5 divided by 18, that is converted into meter per second, kilometer per hour to meter per second, and this calculation is equal to 60 meter per second and 216, this is kilometer per hour. So by using that magnitude, phi is equal to 60 into 60, that means phi square divided by r, that r is given there, r is equal to 72 into 10, z is equal to 10. Okay, z is equal to 10, that is given there. Yes, g is equal to 10. So when we calculate this all, this 0 get cancelled, 360 divided by 72, then 36 2s are 72, so 10 divided by 2, that means is equal to 10 divided by 2 means that is equal to 5. So tan theta is equal to 5. So theta is equal to what is theta? Theta is equal to tan inverse of 5. Tan inverse of 5, then we got the answer that we take that in natural tangent. What about the theta? Natural tangents, natural sine, natural cosine, this is natural tangent. So our answer is tan inverse of 5. Where is 5? Here 5.1, here is 4.7, that means here this is 4.9594, this okay 5.005, that means that is close to 5. So what about the angle, what about the degree here? 78. And what about the this 0.7, that means we get that answer nearly equal to 78.70. Here 75 is there, so we can minus 1 point there, so we can write there 69 or 60, that also correct. Theta is equal to 78.7 degree, so we get the answer theta is equal to 78.7 degree or 70 degree. Theta is equal to, then second we have to calculate there the height. H is equal to what? Here we take the sin theta is equal to what? Sin theta is equal to h upon L. So sin theta is equal to h upon L. So h is equal to what? L sin theta. L sin theta. So L is equal to given, L is equal to 10 sin theta already we calculate, that is 78.70. So h is equal to height, that is equal to in natural sine 7808, natural sine 78 7, that means 9806, 10 into 9806, 0 point, all these points are there, so 10 into 0.9806, so multiply per that we can get 9.806, that is the height. H is equal to what? 9.806 meter, that is the height. Theta and h already we calculate here. Theta is equal to, look here, theta is equal to 79.69 or 70, and height h is equal to 9.8, already we calculate h is equal to 9.806. That is the third example. Next example, that is 15th number. The road is in the question 14 above is constructed as per the requirements. The coefficient of static friction between the tires of the vehicle on this road is 0.8. That means here coefficient of static friction mu s is equal to 0.8 is given. Will there be any lower speed limit? Any lower speed limit? By how much can the upper speed limit? So lower speed and upper speed we have to calculate exceeded in this case. So near about the road in the question number 14 means this question. So we are using that given data in that question. In that question we get the tan theta is equal to what? Already given. Tan theta is equal to 5. In question number 24, tan theta is equal, already we calculate tan theta is equal to 5. So r is equal to, what about the r given in 14th number, r is equal to what? 72 meter. Yes. Okay, we have to calculate phi minimum and phi maximum. Phi minimum is equal to question mark, phi maximum is equal to question mark. Now velocity at the banked road, already we know phi minimum is equal to under root rg in bracket tan theta minus mu s divided by 1 plus mu s tan theta. This is the formula for that. So put that magnitude, phi is equal to under root rg means r is given 72 into g is equal to 10. We have to take that magnitude in bracket tan theta is equal to 5 minus mu s means 0.8 already given here. Okay, divided by 1 plus mu s means 0.5 into tan theta, 0.8 into tan theta, that is 5. Okay, when we calculate that answer, so phi minimum is equal to under root 604.8. this is the answer. When we solve that, we get the answer phi minimum is equal to under root 604.8. so phi minimum is equal to, when we take the square root of this, so we get the answer 24.6 meter per second here. But that answer is given in kilometer per hour. So how to convert that into kilometer per hour? So 24.6 into 18 divided by 5. By multiplying this, we get that is meter per second is converted into kilometer per hour, and that answer we get as 88 kilometer per hour. Here that answer is given 88 kilometer per hour. So phi minimum already we calculate. Phi minimum is equal to 26.6 meter per second or 88 kilometer per hour. So what about the phi max? If we know that theta is equal to tan inverse of 5, because here tan theta is equal to 5 given. So theta is equal to tan inverse of 5. Theta is equal to tan inverse of 5. So we get that answer already we calculate in 14 this problem. So theta is equal to, we calculate 78.70 degree. So from that we can say that as theta is greater than or equal to 45 degree, then in that case phi max is infinity. As theta is greater than or equal to 45, that means that is greater than this 78.7 is greater than this one. So we get phi max is equal to infinity. That means there is no upper speed limit. And lower speed limit already we calculate, that is lower speed limit is equal to 24.6 meter per second or 88 kilometer per second. And what about the upper speed limit? There is no upper speed limit, that is phi max. If theta is greater than or equal to 45, in that case phi max, that is the upper speed limit, there is no upper speed limit, so phi max is equal to infinity. This is the second problem. Next one problem, another problems that we take in next lecture.